Hi there, so we're going to start looking at networks and graphs in Year 12 further now. So let's jump into looking at some of the terminology that we'll be using first up. Okay, so a graph is a network diagram that consists of points called vertices. So our vertices in this graph, for example, will be A, B, C and D. A is the vertex, so vertex is the singular form of vertices, and they're connected by lines called edges, so edge AB, AC, CD, and so on and so forth. Two vertices that are connected by one or more edges they're referred to as adjacent vertices. So if there were two ways to get to A and B, they would be adjacent vertices. An undirected graph is one where there's no direction associated with the edges. So as you can see, A and B, there's no directional instruction, it's just A and B and B and A. So different looking graphs can actually contain the same information. So it's important to take note of not only the labelled vertices but the edges as well. These three graphs, although they look very different, they do actually contain the same information. So as you can see, they've got the same four vertices and they've actually got the same edges. So D to C, D to C and D to C behind the camera there. AC, AC, AB, AB and BC or CB. So they're actually all the same, they just look different. So taking note of what edges and vertices there are is really important. So again, just some more terminology. So we've talked about edges, as you can see here, multiple edges. So two different edges connecting the same vertices. As a loop here, which is one vertex which is connected to itself via an edge. Over here there's an isolated vertex, there's no edges to connect it to any other vertices. Again, a vertex, which is the singular form, and a face in there, that's an enclosed face. Okay, let's jump into doing some work with these graphs. So it's asking us to identify the number of vertices, edges and faces in this example. So let's start off by actually writing down what vertices we've got. So we've got vertice H, B, M, G and W. So there's 5 vertices there. The edges, again, I'm going to write them down. So we've got WH, HB, HG, WG, GM and BM. So 1, 2, 3, 4, 5, 6 and BG, don't forget that one. So 7 edges there. And then the number of faces. So we've got an enclosed face here, an enclosed face here and an enclosed face here. And then we also have the face which is outside the graph, which is included as well. So that will actually give us 4 faces for that one. So that's that worked example done. So then we're going to jump to the second one. Again, we've got HT, that's meant to be an A, HATF. So we've got 4 vertices. Then if we go on to the edges, we've got HT, HF, TA and AF. So 4 edges there as well. Now to do the faces, we're actually going to need to redraw this graph. So I'm going to take a red pen and I'm just going to make a smaller diagram. So we're going to move up here and this we're going to label T. Going to label this one A. So what we're doing is we're essentially unfolding it. So T and A connect. Then we've also got a H here, and F here. So we've simply taken out the intersection in here because there is no vertex at this point, which means that these two, it's not actually considered an enclosed face. So by unwrapping it and changing the graph itself, simply how it looks, so we've kept the same information. You can still see that we've got T to A, which is this one. We've got T to H, or H to T, H to F, and A to F. So again, still the 4 edges and still the same 4 vertices. So the faces we've actually got one enclosed face, and then the space again outside the graph is considered. Sorry, just a slight hiccup there with my PowerPoint. So as I was saying, we've got the enclosed space in here, go back, which counts as one face, and then the space outside, again, a second face. So we've got 2 faces there. So as I was saying, 2 faces for this graph, the inside and the outside. All right, jump on to our next slide. So what it's asking us to do is determine the degree sum for the following graph. So the degree of a vertex is also called the order of the vertex, and the number of edges linked to that vertex. So, and the loops are counted twice. So the degree sum of the graph is the sum of the degrees of all the vertices. So you can see here I've got the equation, degree sum equals 2 times the number of edges. So we're going to have to go and label all of our edges so that we can plug them into our equation. So we've got B to B, because of course that loop counts as an edge. We've got B to E. We've got E to D. And we've got a second E to D there. And then an E to A. So you can see here that we've got an isolated vertex in C, which won't factor into our equation, but I just wanted to point that out. So the degree sum is going to be 2 times the number of edges, which is 1, 2, 3, 4, 5. So 2 times 5, which means that our degree sum is 10. Nice and simple. Okay, so after this quick little video, you should be able to jump into the textbook now and have a look at 10.1 and do question prep 1. You should be able to do all of those. Remember, you may need to redraw some of the graphs so that you can solve how many faces there are, and you should be able to do prep number 2 as well. Again, remember, you may need to redraw some in question 1. I just want to reiterate that. Good luck!